Today, we're jumping right into that amazing space where old-school craftsmanship smacks right into cutting-edge tech. We're talking about CNC woodworking. And look, this is so much more than just robots cutting wood. It's really about a total evolution in how we create things, blending the absolute precision of engineering with the beautiful, unpredictable nature of a living material like wood. And that really leads us to the big question hanging over all of this, right? Can a machine, with all its perfect code and flawless precision, ever really be considered a master craftsman? Well, the answer is a lot more interesting than you might think, and it all starts with truly understanding the wood itself. All right, let's get into it. Before you even think about firing up the machine, you have to know that the secret to a perfect cut is learning to read wood's secret language. You see, every single piece is its own unique puzzle, with its own set of rules and behaviors. Now, if there's one sciencey word you take away from all this, please make it this one: anisotropic. It sounds super complicated, I know, but the idea is actually pretty simple. It just means wood isn't the same in every direction. Its strength, its hardness, how it's going to react to a blade, it all changes depending on which way you cut it. And that one single principle, it dictates every single decision you're going to make. And here's what being anisotropic actually looks like in the real world. If you cut along the grain, it's way easier on your tool. But, and it's a big but, you run a huge risk of splintering the surface. That's a nightmare we call tear-out. Now, if you go across the grain, you're basically fighting the wood's natural structure. This creates huge cutting forces, and you guessed it, your tools wear out way, way faster. It's this constant strategic trade-off. So how in the world do you know if you're making the right call? Well, you learn to read the wood chips. I know, most people just see them as sawdust to be swept up, but to a skilled machinist, oh man, they're like a live diagnostic report. They're telling you the complete story of your cut, everything that went right and everything that went wrong. And we can basically break this story down into three main characters, kind of like a movie. You've got the good, the bad, and the ugly. Each one of these chip types is telling you something absolutely critical about how your tool, your settings, and the wood are all getting along. First up, we've got the shatter. This is what happens when the wood is really brittle, usually because it's too dry, and it literally just splits apart ahead of your cutting tool. Now, on the one hand, these chips cause very little wear on your tool, but on the other hand, they're a massive warning sign. It means your cut is totally uncontrolled, and you are right on the edge of getting that awful tear out. Then we have the hero of our story, the Type 2, or the ideal chip. This, my friends, is the holy grail. This is what you are always, always shooting for. It's a beautiful, long, continuous ribbon of wood that forms when the blade is just cleanly sharing the fibers. Seeing this chip is proof that everything is working in perfect harmony. Your tool, your speed, the wood's moisture, it is the signature of a perfect finish. And finally, the ugly one, the Type 3 chip, which I just call the mush. Honestly, it's not even really a chip. It's what you get when your tool isn't cutting anymore, it's crushing. The wood is just getting plowed out of the way, and it leaves behind this terrible, fuzzy surface. It is a dead giveaway that something is seriously wrong. Okay, so recognizing those chips helps us figure out what's going wrong. Now let's talk about preventing the problems in the first place by really mastering your tools. Because the goal here isn't just to make one good cut, right? It's to make sure your tools perform at their absolute best for as long as possible. And there are a few key levers you can pull here. You've got that classic balancing act between your spindle speed, or RPM, and how fast you're feeding the material. But with wood, you also have to think about heat in a really specific way. You got to factor in the wood's moisture, even its internal chemistry, and maybe even choose some high-tech coatings for your tools. Let's really focus on heat for a second, because it is the #1 enemy of your tools, but not just because of friction. See, when things get hot, this chemical reaction called high-temperature corrosion kicks in. It actually attacks the cobalt binder that's holding the carbide tool together, making the cutting edge literally crumble apart. And this gets way worse when you're cutting stuff like MDF or particle board, because the glues in them act like a catalyst and just speed the whole process up. So knowing the science is one thing, but actually using it when things go south is a whole other ballgame. Let's walk through some of the most common disasters, and think of them not as failures, but as puzzles that we can totally solve. First on our list is tear-out. You might also hear it called chipped grain.
It's probably the most frustrating thing in all of woodworking, that awful moment when you see a chunk of your perfectly smooth surface has just been ripped away.
So what's actually causing it? Well, there are a few usual suspects. Maybe your toolpath is running at a really shallow angle to the grain, or the wood could be way too dry, or maybe it's just not a very dense species, or it could be that you're just being a little too aggressive, trying to cut too much material too fast. Each one of these is a clue that'll help you solve the puzzle. All right, next disaster, the fuzzy grain finish. Hey, remember our ugly friend, that type 3 mush chip we talked about? Well, this is the terrible surface it leaves behind. It just feels rough and hairy because the wood fibers weren't sliced clean. They were basically ripped and torn apart. This is the classic sign of a tool that is plowing through the material, not shearing it. 9 times out of 10, the culprit is a dull tool or one that just has the wrong geometry. But you know what? It can also happen if you're being too timid. If your feed rate or your depth of cut is too low, the tool just kind of rubs against the wood instead of actually cutting it. And you'll see this a lot in softer woods or wood that's really moist. And what about those ugly black burn marks? You see them all the time in woods like cherry or maple. The cause is simple, just too much heat from friction. But luckily, the fix is a pretty clear 3-step process. First, program your tool paths so the cutter never ever sits still in one spot. Second, make sure that tool is actually engaged in the cut. And third, if you're still getting burns, just lower the RPM. That reduces the friction, which is the main source of the heat. All of this brings us right to the cutting edge of the technology itself. Because look, all the knowledge in the world isn't going to help you if you're using the wrong tool for the job. Next-gen manufacturing is all about picking these highly specialized tools that are designed for one specific material and one specific result. Just take a look at this. A tiny, tiny difference in the tool's geometry changes absolutely everything. A tool made for cutting plastic looks almost identical to a woodcutter, but the woodcutter has a lower rake angle. It's this super subtle change, but it's designed specifically to shear wood fibers cleanly. If you use the more aggressive plastic cutter, it would just grab and tear the grain right apart. And the specialization goes even deeper than that. Check out upcut versus downcut end mills. An upcut tool pulls the chips up and out of the cut, which gives you a fantastic finish on the bottom surface. But a downcut tool does the exact opposite. It pushes the chips down. Now, why would you want that? Well, it's a brilliant strategy for holding thin material flat on a vacuum table because it stops the piece from lifting up while you're cutting. So you see, it's not about which one's better. It's about choosing the right tool to execute the right strategy. So if you take one thing away from all this, let it be this. As powerful and as precise as these modern CNC machines are, they're really only half of the equation. True precision, true mastery, that comes from deeply understanding the material you're working with. The science is what makes the art possible. Which really just leaves us with one last question to think about. As this technology keeps getting better and automating the physical act of cutting, what does the role of the craftsman even become? You know, maybe it's less about the hand that holds the tool and more about the mind that understands the wood, chooses the right tool, and programs the machine. What do you think?